Hi, I'm Vanessa Hector.
And I'm Fabrice Telford.
And we are from River City Science Academy.
Today we'll be conducting two experiments. First, the Instastow experiment, and then next, the can crush experiment, as you can see.
The crush can experiment will also talk about the changes of state and matter, in this case water, in equilibrium.
Please remember, when you're trying these experiments, to wear gloves, goggles, and an apron. Materials needed to proceed with this experiment are a hot plate, a tub of cold water, tongs, and cans of soda.
Using the tongs, you want to take the can of soda, place it on the hot stove, and let it sit there for a while. You should be hearing the cans bubbling, and that is the water boiling. You might want to let it rest there for just a while. As you can see, the water is boiling very rapidly now, and steam is evaporating from the cans. Now, in one swift motion, you're going to take the cans and flip them over and place them quickly into the tub of water.
Oh! Do you see that? Hey, next. They have to be upside down?
Yes. And what was the result? The can imploded. Before heating, the can was filled with water and air. By boiling the water changed states from a liquid to a gas. This gas is called water vapor. The water vapor pushed the air that was originally inside the can out into the atmosphere. When the can was turned upside down and placed in the water vapor condensed and turned back into the water. Water molecules in the liquid state are many times closer together than molecules in the gas state. All of the water vapor that filled up the inside of the can turned into only a drop or two of liquid, which took up much less space. This small amount of water cannot exert much pressure on the inside of the walls of the can, so the pressure of the air pushing from the outside of the can is great enough to crush it. The sudden collapsing of an object toward the center is called implosion. Nature wants things to be in a state of equilibrium or balance. To make the internal pressure of the can balance with the external pressure of the can implodes. Hey, air pressure is power.
The next experiment we'll be doing is the Instastow experiment.
For this lab, we will be needing a 150 milliliter beaker, and we'll also be using Instastow, which is commonly known as sodium polyacrylate.
You need water.
Now just grab a little bit of Instastow. You want just enough to cover the bottom, about 60 milliliters.
There we go.
And you also want to add 60 milliliters of water. Now when you polymerize polyacrylate and acrylic acid, sodium polyacrylate is exposed to water. The higher concentration of water outside the polymer than inside draws the water into the center of the molecule via osmosis. Sodium polyacrylate will continue to absorb until there is an equal concentration of water inside and outside the polymer. If too much pressure is added to the polymer, it will burst, which we all know commonly as a leaky diaper, because the same material is used inside diapers. And there you have it, Instastow.